Hey there, welcome to the Physics A&E STEM Challenge. In this video, we will be discussing and investigating the physics concept of free fall. In our experiment, we will be using a 600 ml empty AQUA bottle and the stopwatch app. I will drop the water bottle from my hand to the first floor. So the experiment showed that the time to fall is 1.09 seconds for trial 1, 1.15 seconds for trial 2, and 1.12 seconds for trial 3. From this, I calculate that the average time to fall is 1.12 seconds. Now, I would like to find the height from which I drop the AQUA bottle. We will use the formula S equals to UT plus 1 over 2 GT squared. S is the height of the fall. U is the initial speed, T is the time taken to fall, and G is the gravitational acceleration. We will also assume that G is 9.81 meters per second squared and U, the starting speed, is 0 meters per second. Therefore, S will be 1 over 2 times 9.81 times 1.12 squared, which is 6.15 meters in 2 decimal places. Now I know that the bottle has fallen through a height of 6.15 meters. We will now find the final velocity v when the bottle hits the ground. The formula to be used is v squared minus u squared equals to 2gs. Using the results for the height of the drop, I calculated that the v is 11.0 meters per second. The estimated mass of a 600 milliliters AQUA bottle is 0.015 kilograms. Using the values of the mass and the final velocity, we are now able to calculate the kinetic energy of the bottle when it hits the ground. Using the formula that kinetic energy equals to 1/2 mv squared, I obtained the result of 0.905 joules as my kinetic energy. We can also calculate the gravitational potential energy that is lost by the bottle as it falls. Using the mass of the bottle, the gravitational acceleration, and the height of the fall, I obtained that the gravitational potential energy lost is 0.905 joules. So we observed that the KE and GPE calculated is exactly similar. The uncertainty between KE and GPE is 0%. This is because energy is conserved. The law of conservation of energy states that energy can neither be created nor be destroyed. It can only be converted from one form to another form. This in theory is true. However, in practice, kinetic energy may not be equal to gravitational potential energy because some energy is lost due to air resistance when gravitational potential energy is being converted to kinetic energy as the bottle falls. Air resistance is one source of error in this experiment because it slows down the fall of the bottle, increasing the time needed to fall from my hand to the ground. My hand position, or the height from the ground at which I am holding the bottle, could be slightly different during each trial, possibly causing errors too. To increase the reliability of my readings, I can take more than 3 trials and average results, and I can also drop my bottle from a table so that the height from which it falls at each trial is the same. This part will discuss free fall of the AQUA bottle using a parachute. We need a 30 x 30 cm plastic, 4 30 cm long strings. Connect the strings to the plastic and attach it to the AQUA bottle. The parachute is ready. For trial 1, the time taken to fall is 2.61 seconds, for trial 2, 2.49 seconds, and for trial 3, 2.70 seconds. This gives an average of 2.6 seconds. According to theory, the value of T in part B must be greater than the value of T in part A. My values support this suggested theory. The reason for this is that the parachute's large area increases the air resistance, slowing the bottle down as it falls and making the time it takes to fall longer. Well, that's all for today, guys. Thank you for your attention.